Alright, so today we're going to derive the quadratic formula. And once you know this, you will never have to use completing the square again if you don't want to, unless someone tells you to. So, we know that through the process of completing the square, we can solve any quadratic equation. We know that through completing the square, we can find solutions to anything that looks like this. Right? Whether it was x squared plus 5x plus 7, or, negative 2x squared minus 6x plus 1. We found solutions to all sorts of quadratics. But it's kind of a long process. So, what we're going to do is we're just going to use completing the square to find the solution to this. This is a quadratic equation, ax squared plus bx plus c. Normally there would be numbers for a, b, and c. But what if we just solve it as it is? We can solve this. It's going to seem kind of weird. We're not going to get a number as our answer. But we can totally solve it. So let's go through the steps of completing the square just to figure out where we're headed. What is the first step? What would we do first? Okay, so step one is to subtract our constant. Okay, so we'll do that in a second. What's step two?
Divide by a.
Yeah, divide by a. Okay, step three.
There's a little bunch thing you can find half. Wait, you can't find half of these. Yeah, you can.
So we have to find half of b.
And square it.
Yeah. We square this and then add to both sides. Okay, next. What do we do after that? Yeah. So we factor the side with x. What's going to help us factor?
The fact that it's a perfect square.
Okay, it's a perfect square, and so we know it's going to be x plus,
b over 2.
yeah, this, right? We're going to use this to factor. And then we simplify the other side. Right? 6. What do we do next?
Then you square root everything.
Okay. Square root of everything.
With the plus or minus thingy.
With the plus or minus thingy. Okay.
Then you solve.
Then we solve for x. Okay. You guys ready?
Yeah.
Step 1, what do I do?
Subtract this one.
Yeah, subtract c from both sides. So what do I have?
Ax squared plus bx equals negative. Wait, blank. You need the blank. Not yet.
Not yet.
Divide by a.
What do I do now?
Divide by a.
Okay. I'm going to do it like this. I'm going to divide every term by a. Okay? So this cancels out. I have x squared plus, I'm going to turn this into my coefficient. B over ax equals negative c over a. Okay? What's next?
You have to do the blank. The half.
We did this. We did this.
You have to.
Okay, half of b. Oh yeah, let's leave our blanks. So, the blank equals negative c over a. Blank. So what is half of b over a?
B over 2a.
Yeah, b over 2a.
Wait, negative b over. Is that any?
Oh, huh. Negative b over 2a is the what formula? X equals negative b over 2a is the formula of the... Okay, we use it to graph quadratics.
It's the axis.
The axis of symmetry. Yeah. Totally related. Okay, so how can we square this?
Couldn't it be squared over?
Think about it like this, because then you won't make any mistakes.
Oh, it would be b squared over 4a squared.
Over 4a squared. We could think about squaring the top, squaring the bottom, but the common mistake is, oh, 2a squared is just 2a squared. No, no. 2a squared is 2a times 2a, so it's 4a squared. Okay, so we add that to both sides. Okay, so we've done this and this. Factor this side. So I'm trying to factor this. Yeah, x plus b over 2a squared. Okay, now this is kind of tricky. How do I combine negative c over a plus b squared over 4a squared?
Wouldn't you multiply c times, wait, couldn't you multiply, by 4 over 4? Oh wait, no, because it's
Okay.
a.
You guys have the right idea. I have to get a common denominator, right?
4a.
Yeah, so I need to multiply this times 4a. So I'm going to do that. So negative c over a times 4a over 4a plus b squared over 4a squared. Okay, so negative c times 4a is negative. I'm going to write it in an order that kind of makes sense. Typically we write the variable first, 4, and then we write the coefficient first, and then we write the variables in alphabetical order. So a, c. It is, yeah. Negative 4ac. That's our numerator, and our denominator is 4a squared. Okay.
Would it be negative abc squared?
So now I can combine those, right? How can I combine this into one fraction?
You just at the top, so it would be negative 4, negative 4 a b squared c.
Okay, this is an interesting idea. Is that this plus this?
Oh wait, no, that's that times that.
That's the yeah, that's what we get if we multiply them.
It'd be negative 4ac plus b.
Yeah, that's all we can do, right? Over what?
4a squared.
Yeah, the denominator just stays the same.
Can you just subtract that a? From both sides? I mean, like, simplify the a squared.
From
Like,
this side?
no, over there on the thing, because you have an a
Oh,
and an a.
well, I don't have it in this term, right? So I can't cut out the a here without having it here. Typically, we would write this the other way around. So instead of negative 4ac plus b squared,
b squared minus 4ac.
b squared minus 4ac.
So then you have square root both sides.
Okay, so x plus b over 2a. I'm gonna rewrite it first. B squared minus 4ac over 4a squared. Okay, square root both sides. Boom. What can I do with this? Think back to when you were solving these types of problems, these complete the square problems. What usually happened when you square rooted?
Nothing. Because you can pull out the 4 and the a squared.
Yeah, we can take the square root of this denominator, right? So it's a little simpler. So after this, all I have left to do is to solve for x. So I'm going to erase these steps. these steps. I'm going to rewrite what we have. So right now we have x plus b over 2a equals the square root of b squared minus 4ac over the square root of 4a squared. I can simplify that, can't I? First of all, I kind of forgot something. What did I forget?
Plus or minus?
Yeah, so I want to have a plus or minus here. What can I simplify?
Well, 4a squared is 2a.
Yeah, the square root of 4a squared is just 2a, right? So my denominator is now just 2a.
B squared is just b.
But I can't take the square root of b squared. Why not? If I have the square root of 4 plus 1, does that equal the square root of 4 plus the square root of 1? No. Right? So I have the square root of something minus something. It's not the same thing as the square root of this minus the square root of this. I can only split up the square root over multiplication. But if I have two things added or subtracted under the square root,
And you can't pull
they
out.
just have to stay there. Right, and I can't pull out anything either because those two terms have nothing in common. Okay.
Could you separate the 4 and the a and the c?
Like 4 times a times c.
B squared.
Well, no, because that's within this, right? So I can't take the square root of like one part of this because they're being added together. Right? Think about that same thing again. The square root of 5
But they're multiple.
is not the square root of 4 plus 1.
Wait, no.
That would be 3. Right? The square root of 4 plus the square root of 1
But like
would be
if you
3.
have like 25,
Doesn't work.
if you have like 25 plus 1, and then like, no, it'd be like 25 plus 1 versus 5 times 5.
So you're saying if the first...
But like, okay, so
Yeah,
like,
it wouldn't
could
work.
you pull out just the minus the 4? Because we could do that with the thing down below, or would that not work? Like,
Well, we don't have a negative 4 in this term. Right? There's no negative 4 in b squared.
right, but you
So I
can-
can't pull it out. Right? There's no... When we say pull out, we're talking about distributive property.
Okay, but I mean, like, because we took out the 2 and the a,
Uh-huh.
so couldn't, and if it's multiplying, so it'd be b squared, you could have b squared minus 2, or b squared minus a.
Right, but you're trying to split up the square root between this and this, which we can't do.
Wait, but no, but those are multiplying.
No, they're not. This is being subtracted.
No,
from
the
this.
4 and the a and the c are being multiplied, so can't you break those up?
I can't get the square root over just before I see it.
Never mind.
Because this is one term, right? So it's like, what you're saying is like this. The square root of 5 minus 3 times 4. Right? Is that the square root of 5 minus 3 times 2?
I see.
This would be the square root of negative 7, right? This one would be the square root of 2 times 2. So they're totally different. We can't take the square root of just... Well, that's what, if we took the square root of 4, this is the same thing.
I know, but that's not what I was asking, so it doesn't matter.
Okay. We can't take the square root of just one part of anything, right? The reason is the square root is technically an exponent. So what we have here is we have b squared minus 4ac to the 1/2 power. That's another way of writing that. I can't distribute exponents over subtraction. So I can't take the square root of any part of this. I have to take the square root of the whole thing. Okay? Alright. So now what do I do?
So you have plus or minus b squared minus 4ac over 2a.
So how do I solve for x?
Add b over 2a, or subtract b over 2a.
subtract b over 2a. Where am I going to write it on the right-hand side?
On the left.
It's negative b
Yeah.
over 2a.
I usually write it on the left, right? So I'm going to write negative b over 2a plus or minus the square root of b squared minus 4ac over. Whoa! What's kind of crazy about this?
They have the same denominator.
They already have the same denominator. But remember how that happened? That always happened when you solve these with completing the square. So what can I do now? What can I do now?
Negative b plus square root of b squared.
Negative b plus or minus the square root of b squared minus 4ac over.
The quadratic form.
This is the quadratic form. Any quadratic will have solutions according to that form. Okay, let's do an example.
Wait, could you
I'm not gonna.
memorize this?
Yes, you will memorize that. You will want to memorize it. Alright. So let's say I had something like 2x squared plus. Okay, what's A?
2.
What's B?
4.
And what's C?
1.
Okay. So, all we have to do to know the solutions to that, x equals negative b plus or minus the square root of b squared minus 4 times a times c over 2, oops, sorry, b squared over 2 times a. Oh, now I can simplify that, right? X equals negative 4 plus or minus the square root of 16 minus 8 over 4. Okay. 16 minus 8 is 8, right? That kind of looks like answers that we've gotten, right? Are we done?
Does this make it any easier?
It's up to you. I mean, I think this is way easier than completing the square. It's like 2 steps, and then we're done. But if you prefer completing the square, you can totally still do it.
I don't prefer to see.
I think once you practice this, you'll realize that it's pretty simple. Okay, but what is the square root of 8? Is there a perfect square in 8? Yeah, 4 times 2, right? So it would be negative 4 plus or minus 2 square roots of 2 over 4. And now, what can I do? Does anyone see it? Every single one of these terms has a 2 in it. So I can cancel 2. So the final answer to this one would be negative 2 plus or minus the square root of 2 over 2. I canceled a 2 out of this, right? But I had to cancel it out of every single term. Okay.
Because I can totally graph that.
And what does this equal? What does this equal? X. Yeah. That's the solution. It's like solving for x. But it's a really complicated way of solving.
Because you can graph that point on a parabola.
Well, right now, this is not a point. But if we assume that this originally equals y, right? And so y is 0 and x is this, then we could try to graph it. But yeah, it would be pretty miserable.
Are you gonna try to teach him how to graph?
It would be pretty miserable to try to graph that, right? You'd have to like get out your calculator, figure out where that point is, and then like estimate, because it's definitely not right at a number.
Just get one of those definite calculators and it's online.
That's right, you could use a graphing calculator.
-2.
Okay, let's do another one. 3x squared minus 6x minus 4. Solve it.
3 and 6 are
Okay.
6
A equals 3.
and 3.
What is B?
6.
Is it really? Negative 6. That's super important. Okay, and C is
Negative 4.
negative.
And then when you
Okay.
put it in,
X equals,
negative B, which is, so it's just 6
so positive 6
plus or minus
plus or minus.
the square root of negative. Wait, yeah, that's right.
A negative 6 squared is what?
36.
Yeah, 36. Okay. Now I want to point something out here. 36. Normally we would say minus 4AC, right? What I like to do is look right away. I have a minus. A is positive and C is negative. So the minus becomes a plus because we have minus a negative. We have minus exactly one negative. So what we have here is plus 4 times 3 times 4. So this is kind of a shortcut. Instead of having minus and then negative 4, I just combine those right away. I like to try to notice that as I'm writing it down. Okay, all over what? 6. All right. Equals. So first we're going to simplify this. Can I cross out this 6 and this 6?
No, because it's 6. Oh, because you need the 6.
Right. Think about just like a simple fraction, like 6 plus 1 over 6. We know that that equals 7 sixths, right? If we crossed out these 6s, that would be 2, right? 2 over 1. I mean, it said 2 over 1. So is 7 sixths equal to 2? Not even close, right? Wait, if we want to cross something out, we have to be able to pull it out of the entire thing.
But if you pull it, you can pull it.
Not yet. The first thing we're always going to do is simplify this thing under the square root. This is kind of like the tricky part of the quadratic formula, simplifying. So I have 36 plus what?
48.
Yeah, 12. Well, it's plus because this 4 was negative, right? It was minus and the negative, so it became plus. Right?
Yeah.
Okay. So we've got 6 plus or minus the square root of 36 plus 48 over 6. Okay. What is 36 plus 48? Six plus or minus square root of what?
Oh,
84, right? Okay, 84 has a what? Yeah, which one?
no, not. This is that we don't know square root. 4 and this one.
Right?
Oh. Oh, there. Oh.
So we can do the square root of 4, which is 6 plus or minus square root of 4 square root of 21 over 6. 6 plus or minus 2 square roots of 21 over 6. And then we can cancel a 2 from everything. So our final answer is 3 plus or minus the square root of 21 over 3. And
square root of 4 and square root
Yeah, how come I can do this, but I can't like take the square root of 36? Because these are multiplying, right? So remember, square roots are like exponents. They distribute over multiplication. They don't distribute over addition.
How did you get rid of that 2 again?
I canceled it from every single thing. So just like I couldn't cancel the 6 here, I can cancel a 2 because the 2 is in every single term.
Okay. But the square root is just equal to that.
The square root got simplified because 84 has a perfect square in it.
You know, but like you don't, like when you're simplifying, you don't include the square root in that, right?
Well, I'm including the term that has a square root, right? Because it's 2 times the square root of 21.
But then couldn't you also cancel out the 3 since you canceled out the...
Yeah.
Well, is there a 3 in every term?
But no, but you didn't count 21 or 21 as...
Yeah, I did. I canceled the 2 that was multiplied times that.
Oh, okay.
Right? 2 times the square root of 21. Just like 6 is technically 2 times 3, right? And I'm canceling just the 2 part of it. Does that make sense? For some reason, this is always really tricky. I'm not sure exactly what it is. But it's going to become very, very important. Because kind of the last subject that we'll look at in Algebra 1 is called simplifying rational expressions, and it's all about doing this with really complicated things. I know. It's awesome. All right. So that's a quadratic formula.
The erasers are actually functioning now.
Yeah, I cleaned them.
How do you erasers?
I just cleaned them.
With chalkboard
With-
with it?
Sort of, with like a paper towel. Seemed to work. So tonight for homework, I'm just going to have you I'm going to guide you back through the process of completing the square with ax squared plus bx plus c. In other words, deriving the quadratic formula. Okay, so you'll see, let's see. So on your homework, I have like written out all the steps, right? But I've left blanks. So everywhere there's an arrow and a number, you're supposed to fill something in. And then over here, I underlined what it is you're supposed to fill in. So like this says, this is the original equation, and that original equation is underlined. Oh, I forgot to put an arrow there. Okay, well I messed up on the very first one. That should be the first thing that you fill in, is that very first box. So what is the original equation?
And we can choose.
What did we start with? Look back at your notes. You probably could look at the second one to help you. But what should go in this very first box?
Oh,
AX plus B, AX plus C
Ax squared plus bx plus c, is that an equation?
equals 0.
Equals 0.
Oh.
Equals 0. Yeah. Okay, and then it says, move the loose number to the other side.
Oh, that's...
And it says ax squared plus bx equals, and then there's a blank and an arrow.
Negative C.
So you'd have to fill in that negative c. So I would highly recommend that you keep your notes with you to do this homework. Okay?